Okay, so now we're going to learn how to use polynomial functions to help us solve word problems and find minimums and maximums. So if we look at example 1, we have a rectangular dog pen is constructed using a barn wall as one side and 60 meters of fencing for the other 3 sides. Find the dimensions of the pen that give the greatest area. So I'm going to label, I've drawn a picture of the pen. I'm going to label the vertical sides as X, the horizontal side as Y. This red side is the barn, so it doesn't have anything to do with our problem right now. So when we know that the length of the fencing is 60 meters, therefore we know that x plus y equals 60. 2x plus y equals 60. That's good. And then we also want to find the dimensions of the pen that give us the greatest area. So how can we make a equation for area? Well, area is just x times y. So now we want this to be a function. We want area just to be a function of x. Right now it's a function of both x and y. But how can we get this just in terms of one variable? We can use this. So we can see from this that y equals 60 minus 2x. And then we can just plug that y in here so that we have our area just as a function of a single variable. And then if I multiply this out, I'll get negative 2x squared plus 60x. So now I have a quadratic function in standard form here with a as negative 2 and b as 60. And now I need to find the dimensions of the pen that give us the greatest area. So I basically want to find the maximum area. So when we're dealing with quadratic functions, what is the maximum point? It's the vertex. So I'm going to go ahead and start finding the vertex. So the x-coordinate of the vertex is going to have to be negative b over 2a, or our axis of symmetry. So that's going to be 15. So we know that to make the maximum area, our x variable is going to have to be 15. So I can fill that in here now. I know that now. Okay, so if I plug 15 back in here, a of 15 if I do this out, that's going to be 450. So now I know that the area is 450, and I found that vertex, which was 15, 450. Now the question asks me to find the dimensions of the pen. So I already found one. I found that the vertical length is 15. Now I need to find the horizontal length of y. How can I do that? Well, I can go back here and see that 2x plus y equals 60. So if I have 2 times 15 plus y equals 60, I can just solve for y, see that y equals 30. So I can come back here and find that we have 30, and now I've solved my problem. I know that the dimensions have to be 30 meters by 15 meters. So how we did this problem is we set up a quadratic function for the thing that we were looking for. We found the maximum using the vertex, and then we solved for x and y.